Well, howdy y'all. So just picking right up where we left off. This is going to just be a quick little touch on changing dimensions. Nothing too dramatic. So when we're changing dimensions, we're taking some object, okay, and we're making it bigger or smaller. But we're consistently multiplying all the dimensions by one number called a scale factor. There is asymmetrical stretching and shrinking, and you may deal with that in future classes. But for now, we're going to keep everything consistent. All right. We have dimensional change, which can be perimeter, like here, area, which we've done, and volume, which we've done in 3 dimensions. Okay. So let's go ahead and get started. Now this table actually is pretty darn important for figuring out things. Now I have a whole proof. I have this on YouTube as well. Maybe my area chapter though in geometry, so I'd have to look it up. But I've gone in much more depth. So what we have here is sim ratios, and this goes back to our similarity unit, and that's probably where I have this stuff at. I'm not going to redo all this because of time considerations. But when we have ratio of the corresponding sides, 2 to 3, which very often we can write of that. So basically imagine having a rectangle of 2 and a bigger rectangle with a 3. So the ratio of one side over another is 2 to 3. The ratio of the perimeters are going to stay the same at 2 to 3. But ratio of the areas, we're going to double it. We're going to do 2 squared to 3 squared. And ratio of the volumes, which I don't have up here, okay, is ratio of the volumes is going to be 2 to the 3rd to 3 to the 3rd. Okay, it can get quite a bit big, which this is going to be 4 to 9, and this is going to be 8 to 27. So if I was given ratio of the perimeters, I know that this would be the same. And this would be 25 to 49. And this would be 5 cubed, which is 125, to 7, which is what, 280, no, 263 or something like that. Okay. So, no, it's bigger than that. I'd have to look, I'd do it. So it's going to be 5 to the 3rd to 7 to the 3rd. Okay. If I give you ratio of the areas, you just take the square root of 9 to 8. And that would also be the same here. Okay. And here this would be 9 to the 3rd to 8 to the 3rd. Really big numbers. So that would be ratio of the volumes. Now, but what we're going to do is we're going to just find things like sim ratio or find the ratio of the sides, and maybe use that in the future. So here I'm giving you volume. This is 3D. All right. So basically we need to take the cube root if we're given the ratio of our volumes. So if we have 729 over 1331, we're going to take the cube root of 729 and the cube root of 1331. In the calculator, you just go to that menu right there, put in your cube root, and you're going to have 9 over 11. So this side could be any ratio of 9, and this could be a ratio of 11 right here. Okay? Alrighty. So, this one. Find the ratios of the perimeter and the area. Find the missing area. Very typical problem. So, area is 2-dimensional. Okay? That means we're going to have our sim ratios squared. Sim ratio is 2 over 6. And we're going to compare that to areas of 2 over x. We don't know the new area. That's just 1/3. So 1/3 squared is 1 over 9. This is just equal to 1/3 squared. Okay. It's equal to 2 over x. Cross multiply. X is equal to 18. So the new area is equal to 18. Now reports have said that these are starting to show up on your SATs. So you want to be somewhat familiar with them when you go back and get that big SAT book and start studying for that test. What did they give us here? I got these notes from online, so I really should have probably worked some of these out beforehand. So what we have is area. This one is 198. Area this one is 88. And this side is 10, so I'll call this side x. Okay? So we're going to do our sim ratio, which is x over 10. Since we're dealing with the area, we're going to square it. And we're going to do left over right, because I have left over right here, over 88. This is nothing more than x squared over 100 is equal to 198 over 88. Well, don't have to cross multiply. I'm just going to multiply by 100 on both sides. So I have x squared is equal to 198 times 100 over 88. So I'll take square root on both sides. I have x is equal to square root of 198 times 100 all over 88. When I put that in the calculator, let me do that real quick. I get, what do I get? 15. Okay, because this is nothing more than square root of, well, they made that easy. 225. So x is equal to 15. All right. So this length is 15. Moving on. There's easier ways to do these. If we know that the volume is three-dimensional, okay, we're basically going to take this 30 and multiply it by our scale factor of 2, 2, and 2. So that's going to be 2, 4, 8. 8 times 30 is 240, all right? So it's equal to 240 meters cubed. But I still could have done this. If I have a scale factor of 2, that means our sim ratio is 1/2. Because 1 to 2 is a scale factor of 2. I could have done it like this. And since it's volume, we're going to cube it. It's equal to 30 over our unknown bigger area. I'll get the same exact answer. So basically on these, and you're only going to have like one homework problem on these, and you won't probably see it again for your rest of your high school. Depends what class you take. You have 30 times 2 times 2 times 2. So you take your scale factor, volume, three-dimensional, 3 2's. If it said area, it would have been 2. If it said perimeter, that's one-dimensional. You just done it once. Okay? Alrighty. So here's my sim ratio. I'm going to write that down as a fraction. Now I'm doing volume, so I immediately am going to cube this. Alright. And the smaller cone is 108, so that goes on top. Pi. And we don't know the bigger, so I'm going to cross multiply. First I'm going to clean this up. 3 times 3 times 3 is 27. 5 cubed is 225. Got that over x. Cross multiply and then divide. I'm going to have x is equal to 108 pi times 225 over 27. I did put this one in the calculator and I got 500 pi, which is 1570.8. Next. Whoa. Last one. So here, 3/5 is my fraction. Now I need to decide if I'm one-dimensional, two-dimensional, or three-dimensional. I am doing lateral area. That's two-dimensional, so I'm going to square it. Okay, small on top, big on the bottom. Area of the larger one is 81, so that goes on the bottom, and I have x on the top. Okay. So I'm going to cross multiply. All right. And so when I cross multiply, that's going to be 9 over 25 is equal to x over 81. So I'm going to multiply, so I have 9 times 81 over 25 is equal to x. Right? And I am going to put this in the calculator because I didn't work this one out. So 9 times 81 divided by 25 gives me 29.6. 29.16. Okay? Meters squared. Alrighty. So height of one person is 3/5 of the other. Lateral area is larger, so I put large on bottom. 9/25, 25x. I made a mistake. Let's go back and erase. I thought something didn't feel right. That area should have been a little bit different. Okay. So when I do this, I have 9 over 25 is equal to x over 81. Cross multiply, that's 25x times 9 times 81. So I think I did it right. No, I did it right. Okay, yeah, it was all good. Alrighty, so I will get it going. Alright, take care.